Good morning, students. This is our second lecture of electrochemistry. In the first video lecture of electrochemistry, we have discussed about electrochemistry, what is its importance, and electrochemical cell. So our next topic is, in case of Daniell cell, the electric potential of 1.1 volt. Electric potential of Daniell cell is 1.1 volt when concentration of its ions is unity. Concentration means their ions, zinc plus 2 ions and copper plus 2 ions are concentration is unity. Thus, when we apply external potential, three conditions may be occur. When we apply external potential of any cell, then three conditions may occur. When external potential is equal to the potential of the cell, or it may be less or greater than potential of the cell. So for Daniell cell, the electric potential is 1.1 volt. When we apply external potential is less than 1.1 volt. So the electron will flow from, two electrodes are present, zinc to the copper. Zinc is present at the anode and copper is present at the cathode. So the electron flow from zinc. Zinc undergo oxidation and electron flow from zinc to the copper. So current will flow in the opposite direction from copper to zinc. Current will flow from copper to zinc when external potential is less than 1.1 volt. In second case, when external potential is equal to 1.1 volt, when external potential and potential of the cell becomes equal, then cell stop working. So here no current is flow, no electron flow or current, so no chemical reaction will takes place. In the third case, when external potential is greater than 1.1 volt, when we apply the external potential is greater than potential of the cell. In this case, electron flow from in opposite direction. In the first case, when EMF external potential is less than from zinc to copper, in this case copper to zinc, or current will flow also in opposite direction. In this case copper to zinc and here zinc to copper. Now this electrochemical cell, Daniell cell is electrochemical cell, will act as an electrolytic cell. Electrolytic cell, the cell in which electrical energy is used to bring about the reaction, which is non-spontaneous. Non-spontaneous means रिएक्शंस जो इलेक्ट्रोकेमिकल यहाँ पर इलेक्ट्रिकल एनर्जी का यूज करके हम किसी रिएक्शन को करा रहे हैं, जो रिएक्शंस ऑलरेडी नॉन स्पॉन्टेनियस उसको स्पॉन्टेनियस में कन्वर्ट किया बाय द यूज ऑफ इलेक्ट्रिकल एनर्जी. सो दिस टाइप ऑफ द सेल इज नोन एज द इलेक्ट्रोलिटिक सेल, which is we will study in next. Next topic is represent, how you will represent the galvanic cell. We take an example of Daniell cell. For the Daniell cell we know about the electrode, zinc and copper electrode. In the left side we write left electrode on which oxidation occur, and on the right side we take the electrode which undergo, the ion which undergo reduction. So here first we write the metal, then one dash into the metal ion which convert after the oxidation. In the bracket we write the concentration of this ion. This represent the salt bridge. Double line represent the salt bridge. Again here copper plus 2 ion into copper, metal ion into metal. Here metal to metal ion, and in this case metal ion to metal. Left electrode, written here left, electron flow from left electrode to the right electrode and current will flow from right to the left. We have already discussed about lone and RCCP. In the left side electrode, lone, left side oxidation occur, act as anode and it is negative. RRCP means right side reduction, cathode, and it will be positive in sign. This is the representation of galvanic cell. So our next topic is electrode potential. What is electrode potential? Electrode potential is defined as tendency of an electrode to lose or gain electron. मीन्स किसी भी इलेक्ट्रोड की वो टेंडेंसी या क्षमता जिससे क्या है वो इलेक्ट्रॉन्स को लॉस या गेन कर सके when it is in contact with solution of its ions। अपने ही सॉल्यूशन के आयंस के जब ये कांटेक्ट में आएगा तो किसी भी इलेक्ट्रोड की जो टेंडेंसी है इलेक्ट्रॉन्स को लॉस करने की और गेन करने की, देन इट इज कॉल्ड एज इट्स इलेक्ट्रोड पोटेंशियल। So electrode potentials can be of two types. It may be reduction potential and it may be oxidation potential. If oxidation occurs with respect to standard hydrogen electrode, all the potentials we compare with the standard hydrogen electrode. If with respect to hydrogen electrode oxidation occur, then this is known as the oxidation potential. Electrode potential is known as the oxidation potential. And when reduction occur with respect to standard hydrogen electrode, then electrode potential is known as reduction potential. Next point is standard electrode potential. When we take standard condition and we measure the potential, then it is known as the standard electrode potential. In any half cell, when metal rod is suspended in solution of, solution किसका 1 molar concentration for the standard condition should be 1 molar concentration, temperature should be normal 298 Kelvin, then the electrode potential is known as the standard and it is represented by E naught. When the condition are standard means temperature is 298 Kelvin, concentration of the solution is 1 molar. So now we are taking an example of standard hydrogen electrode. Here is the diagram for the standard hydrogen electrode. We take a beaker in which 1 molar HCl solution, concentration of HCl should be 1 molar. Hydrogen gas is passed through this. Platinum electrode is present, platinum foil coated with the platinum black, and hydrogen gas is passed from here. This is the connecting wire which connected. So the condition for the standard hydrogen electrode is hydrogen gas is passed at 1 bar pressure. Pressure should be 1 bar. Concentration is 1 molar HCl solution and temperature is 298 Kelvin. In which a foil of platinum coated with platinum black remain immersed. This is platinum foil coated with platinum black is immersed in the HCl solution. Now it is represented as the standard hydrogen electrode potential is written as H2, gas is passed, it converts into H plus and undergo oxidation. Standard hydrogen electrode potential at 298 Kelvin we measured, it is equal to 0.00 volt. It is standard hydrogen electrode potential. Okay students, if we want to find out the electrode potential of any half cell electrode, then we use one electrode as the standard hydrogen electrode and use other electrode which we have to find out the electrode potential. So to determine the electrode potential of any electrode, किसी भी electrode का जब हमें क्या निकालना है electrode potential, it is set up using this electrode as one electrode, जिसका हम electrode potential find out करना है, it is set up as a one electrode and the second electrode to complete the cell is the standard hydrogen electrode. So we use the standard hydrogen electrode as one electrode और जो दूसरी जो हमारी इलेक्ट्रोड आएगी वो जिसका हमें इलेक्ट्रोड पोटेंशियल फाइंड आउट करना है. So by using these two electrode we set up a cell. Then EMF of the cell can be calculated as E naught of the cell will be equal to EMF at the right side electrode and EMF in the standard condition right hand side and in the left hand side. अगर हमें क्या है E naught L, it means it is the standard hydrogen electrode. If hydrogen is taken on the left hand side, then its EMF will come out to be 0. If this value is 0, then EMF of the cell will be equal to E naught at the R. We can calculate the EMF of this electrode. We know that reduction and oxidations are just reverse process to each other. If we have given the electrode potential, that is reduction potential, then we can just reverse its sign, we can calculate its oxidation potential. और अगर हमें oxidation potential given है, then we can find out its reduction potential simply by changing the sign. So we can calculate या we can determine the electrode potential for any electrode. Example अगर इसमें हम देखें, if we take one electrode as a zinc electrode, so zinc should placed at the anode, in the left side in the cell, and second is standard hydrogen electrode. We can find out the standard electrode potential for the zinc, and if we want to find out for the copper, then in the left side we take the standard hydrogen and copper is taken in the right hand side, because electrode potential of copper undergo reduction, and when we take zinc undergo oxidation. Next point is EMF or cell potential of the cell. What is EMF या potential, cell potential of the cell? It is simply the difference between the electrode potential of two half cells. दो half cells के potential का जो difference होता है, that is called as the EMF or cell potential of the cell. And it is called EMF of the cell because this is measured when no current is drawn from the cell. Cell से जब हमने क्या है, कोई current को draw नहीं किया है, then it is called as the EMF of the cell. Okay students, our next topic is Nernst equation, and it is very important. So let's start Nernst equation. First of all, what is Nernst equation and where it is applied? When electrolyte concentration is different from 1 molar, in the standard condition we take the concentration is 1 molar. If concentration of the electrolyte is different from 1 molar, and if the standard condition of temperature is 298 Kelvin, if we take temperature different from standard condition, that is different from 298 Kelvin, then electrode potential has a different value from their standard. If we take different conditions from the standard conditions, then electrode potential is also have different values. This value is obtained by using the Nernst equation. Nernst given equation which is used when conditions are different from standard condition. According to this equation, we consider a general equation. This is Mn plus. A ion is given having the N plus charge. So N electrons are required to reduce into the metal. So Mn plus N electron undergo reduction to give the metal. Then apply Nernst equation for this. For this, the EMF of the cell is equal to E naught of the cell. E naught EMF in the standard condition, and it can be calculated ER minus EL, means reduction potential in standard conditions for the cathode minus standard reduction potential for the anode. In both cases we take only reduction potentials. So it is EMF of the cell is equal to E naught of the cell minus RT over NF ln natural logarithm concentration of metal by concentration of its ion, or we can say that concentration of product by concentration of a reactant. Here R is gas constant, T temperature at which reaction proceed, at which cell proceed, and number of electron transferred, such as in the case of zinc it accepts 2 electron, so N value is 2. Here value of N is 2. In case of aluminium it is 3. It is different for the different types of the electrode. F is the Faraday constant. Faraday is value of 1 mole of electron 96500 coulomb. For the pure solid, liquid or gases at 1 atmospheric pressure, their concentration is taken as unity. Unity means equal to 1. So we take this concentration is equal to metal ion is taken as 1. When we put the value of R 8.314 joule per Kelvin per mole, Faraday 965, temperature is 298, and natural logarithm convert into log 10, then this value will convert into 0.0591. N is variable. It is different for different types of the electrode. So Nernst equation will modify in this form. EMF of the cell is equal to E naught of the cell minus 0.0591 over N log 1 over Mn plus. If there is also ions is present in the product side, then we write it here. Concentration of these ions are written here, and concentration of reactants are written in the denominator. This is very important concept for the numerical portion as well as theoretical portion. Thank you students. We will continue our unit in the next video lecture. Thank you.